Recording in progress.
Okay, example 2, part A. Usually when this happens, when you have a sine and an inverse sine, they should knock each other out. For example, if I have like the square root of like, say, 5 squared, I know what the answer is. It's 5, right? I know that because they're inverses of each other. I expect that. So for example, let's say I have the inverse sine, and again, you don't have to write this down, but like, what if I had this, right? Well, what's sine 30 degrees? I know from the unit circle, I know it's 1/2, right? And what's the inverse sine of 1/2? Remember, to do inverse sine, the output's an angle. What angle gives me 1/2? Gives me a y-coordinate 1/2 on the unit circle. 30 degrees, exactly. It comes full circle, right? And actually, I don't know why I closed my unit circle. That actually would be helpful. So let me pull that up right now. Unit circle, there we go. Yeah, sure, yeah, totally, yeah, 100%. Yeah, so let me just clear my screen for a moment. Where's a y-coordinate 1/2 in the unit circle? Definitely at 30 degrees. It's also over here too. But remember our default range for inverse sine was from -pi/2 to pi/2 inclusive. So I state 30 degrees. So that's how you could handle those kind of problems, is you just do the inside function first. That's 1/2 inverse sine 1/2 is 30 degrees. Now, another way you could think about too is that these are identical, right? Almost identical. They undo each other. So you could think of it, oh, then it'd just be 30 degrees, which for the most part seems true, but sometimes it's not. Like, for example, what if I change up to 150? What if I made that 150 degrees? Isn't sine 150 still 1/2? Yes. But what's the inverse sine 1/2? It's not 150. It's still 30 degrees, right? So even though I'm doing the inverse sine of a sine, I'm doing two functions that undo each other. You can't assume that the answer is going to be that. You actually have to go through the motions and say, okay, well, let's work out sine 150. Let's do the inverse sine and respect the default range that goes with it. Because why do we have default ranges in the first place? We want to force the issue of sine being a one-to-one function, or the inverse being a function itself passing the vertical line test, or the irregular passing the horizontal line test. So it's 1-to-1. So you can't just just wipe these out and say the answer is 2/3. You actually have to be kind of a little more intentional about what you're doing. Now, of course, fortunately, inverse sine of 2/3, that's in the first quadrant because sine is positive, right? So you can think like this, and that's root 5. And then, so all this is supposed to be theta. What is that exactly? I don't know, some weird angle. You have to use a calculator to do that. You actually have to go in the calculator and type that in. And it's going to give you some funky answer, like maybe 50, 40, I don't know, some angle, right? But if I do the sine of it, I get back to 2/3. So the answer is 2/3 for that one. And why was this undefined? Why was this not possible? Yeah, that goes outside my domain. Remember, we had a restricted domain for inverse sine from -1 to 1. 3 is outside of that. Plus the fact that how can I get an output of 3 for sine? That's impossible. Because if you think about it, if I draw a triangle again, so 3 as a fraction is 3/1. That's impossible. That hypotenuse can't be more than the leg. That just can't happen, right? So not possible. All right. Now here, the answer is pi/7 straight up. I could assume that because that's the first quadrant, and it's part of my default range. I don't see pi/7 in the unit circle, obviously, but whatever it is, it's some wacky number. If I do the inverse cosine of it, what's the default range for inverse cosine? From 0 to pi. Pi/7 fits in that, so that's okay. We're okay with that. But let's look at D now. What's the default range for inverse tan? From -pi/2, non-inclusive. So your angle has to be between those. 2pi/3 does not fit in that. Not at all. But do I know what it is? Sure. I know my unit circle. That should be root 3. So second quadrant, that should be root 3. Now, on the unit circle, isn't tangent y over x, right? You're correct. Thank you, -√3. My apologies. Thanks, Sean. Should be -√3. So it has to be in this default range. You want y over x to be that. Let's look at my unit circle. Where's y over x? Negative root 3. Y over x can be negative root 3. Definitely over here. Sorry, my bad. Over here. Because if you do y over x, you do get negative root 3. We do root 3 over 2 over negative 1/2. So definitely could be 2 pi over 3. But that's outside the range. Exactly. Where else does that happen? Or 300 degrees. But we don't want to say 300 because 300 is not between negative 90 and 90. Or 5 pi over 3 is not between negative pi over 2 and pi over 2. So what do you say, Thomas? Negative or negative 60 degrees. Exactly. So we got to say negative pi over 3 or negative 60 degrees. So hopefully that might clear some things up from the homework. Now I'm not feeling as rushed about this. So yes, they do knock each other out, but it's not 2 pi over 3. You have to really kind of go through the motions. And likewise with these here. For E, I know sine 5 pi over 4 is it's a negative root 2 over 2. Now that's the y coordinate. Where's the y coordinate negative root 2 over 2 in the unit circle? Definitely at 5 pi over 4, but where else? At 7 pi over 4 or negative pi over 4? Because negative pi over 4 is coterminal 7 pi over 4. Or negative 45 degrees. And lastly, inverse cosine of negative root 3 over 2, that's the x coordinate. Now, what's the default range for inverse cosine? From 0 to pi, right? So you have to only focus on 0 to pi. Let's pull up the unit circle. Where is that negative root 3 over 2? Where, Thomas? Q2 or 150, right? 5 pi over 6. So that's going to be cosine of 5 pi over 6 or 150. And what does that equal? That equals negative root 3 back. It comes back full circle. So in that case, yeah, sure. These knock each other out and I get negative root 3 over 2, sure. But we have to be careful about this. Okay. Hopefully that makes sense. So really, this is yet another extension of unit circle. Okay. And I think what would probably help as a homework quiz for Monday would be this kind of stuff. Because I think just, like unit circle, but a little different. You got to now give me the angle as the answer, not the coordinates of the unit circle or the ratio sides of a right triangle. Okay, example 3. Remember what I said about any inverse trig function? That's always going to equal theta. That's always going to equal theta. And then you got to do the sine of that angle or the tangent angle for A and B respectively. Now, I'm going to draw, and I did this fast, so I'm being slower about this. Inverse cosine. That's negative on the inside. So what quadrant would I be in? So you want a Q2. I'd be Q2. So draw a triangle in Q2. And I told you I love these problems. I really do. These are good problems. So that's negative 5 and 7. Zay, go ahead.
How do you know it's like negative 5 over 7 or 5 over negative 7?
Great question. Great question. So, and actually I should clear that up. That's fantastic. So the negative can go to either one, obviously, right? And what is cosine general? Adjacent or hypotenuse. Always keep hypotenuse positive. The legs can change sign. The hypotenuse does not. And because now, think about it, the horizontal leg, is it on the positive x-axis or the negative x-axis? It's on the negative x-axis, right? It's pointing left. Now, the vertical leg, is that pointing up or down? That would be positive. So if I, of course, if I square root, it can be plus or minus, and I solve it. But if I solve it, what do I get for that leg? If I get that in theorem?
2 root 6.
2 root 6 root 24, or simplifies 2 root 6, right? Good. That's fantastic. Now I want the sign. What's the sign of that triangle? Positive 2 root 6 over 7. As it should be, because I'm in Q2, right? Sign's positive in the second quadrant. So I like these problems because it really kind of forces you to use a lot of the different skills we've learned. And it's very, what's the right word to use? It just does a great job combining a lot of different concepts. So, okay.
And we know it's not in Q4.
It's not part of my default range. It's not part, my default range from 0 to pi.
Range for cosine?
Inverse cosine, correct. Okay, now for B. Ooh, that's a lovely one. What quadrant am I in here? What quadrant? 4, yes. So you could draw it like this. I'm gonna make that negative 3 and that 8, because that's O. over h, -3/8. Pythagorean theorem should be root 72, I think, or 6√2. Is that correct? Did I do that correctly? I think so. Yeah. Now I want tangent. Tangent is going to be this. And personally, I do not care if we rationalize the denominator. You can leave it like that. We probably should reduce it a little bit. Maybe we could do that. I accept either answer. Say, go ahead.
I think,
What did I make a mistake?
no, it's root 55.
Okay, what mistake did I make, guys? Yeah, you're right. I made a mistake. What did I assume the hypotenuse was? I assumed it was 9. Because I did 81 minus 9. Made 72. That's my fault. Yeah. So I'm human. I totally made a mistake. My apologies. So what is it again? Roots.
55.
Yeah, there we go. Much better. My apologies. Sounds like a highway, root 55. All right, -3 over root 55. Okay. Get much better? Okay. All right. Now let's talk about some of your stuff. Okay. And I'm just looking at the clock. We're good. We're doing great on time. Doing great. Okay. And again, I still want to talk about homework too. I still want to leave a little time for it, but hopefully that discussion might clear up some homework questions. And I feel like I kind of closed the loop on part 5 of the notes. Okay, now part 6. So how do you graph an inverse cosecant? Well, if I look at cosecant in general looks like this. Now, there's more to it, of course, obviously. It should really be more like this, right? Okay, let's take a step back. Okay, let's take a step back. Okay, so cosecant looks like that, right? Does that pass horizontal line test? No. We want to force the issue of having it pass horizontal line test. Well, I'm not going to keep this one cycle here, or this one portion of the cycle. So if I go from 0 to pi, that's just gonna, that U shape's gonna totally fail. So I have to take, if I want to make sure I cover all possible outputs. So I'll take the left half of this and right half of this, or go from -pi/2 to pi/2. So this, and it's not inclusive, by the way. That's why you see that as the sorry, 0 is not included. That's what I meant to say. 0 is not part of our domain, but -pi/2 and pi/2 are part of our domain. And the range, we know the range is from -1 to -1, from 1 to infinity. We want to make sure that's all included. So I'm going to get rid of all this. That way I force the issue that's a one-to-one function. And therefore its inverse will also be a function. Now, how do I graph the inverse of it? It's a little tricky, but you could use Desmos if you need to. But let's just make a quick table. So let's just reverse x, y coordinates. √2 pi/4, 1 pi/2, -√2, -pi/4, and -1, -pi/2. So that's 1 and 2. And again, we could easily punch the Desmos, but let's do this by hand so we really feel we got a good handle of this. So 0.1 comma pi/2. √2 is roughly what as a decimal, would you guys say? Yeah, 1.414. Good. I like that. And here, your vertical asymptote is at x equals 0. So what's the inverse of that? Is that a horizontal asymptote at what now? At y equals 0. Exactly, at y equals 0. And it totally fits the domain, right? Sorry, let me take it back. It totally fits. So domain and range have to switch, right? So what's my domain now? It's from negative infinity to -1 inclusive for -1. Union 1 to infinity. What's my range? That's gonna be the domain from before. So definitely I don't get 0 for my range. But it's going to go from but it has to stop at pi/2 negative pi/2, obviously. So it looks like this. So everything's reversed from the cosecant graph. It's all reversed. And that's why when we look at the homework problem, if you look at the solution key, yeah, see how it looks like that? Inverse cosecant. Yeah, right there. Okay, so we're okay with that? Okay. So the inverse secant works the same way. Before we do that, let's fill this out. So again, unique angle y in the interval. So wonder what's meant by that. Well, y equals the domain again was from negative infinity and the range was this from so double checking the homework again. Yep, that's exactly what I see there. Yep. I don't know what's meant by the blank there. To be honest. Oh, geez, I just close it. Lovely. Let's open the notes again. There we go. Yeah, I don't know what's meant by that first one. Unique angle y in the interval. Oh, it's an interval from yeah, or negative pi/2 to I think it's supposed to be negative pi/2 to pi/2. Oh no, because we were going from what to what. We went, yeah, no, that's right. Yeah. That's right. We did this. There we go. Sorry, that's what I meant to say. And that 0 should be a parentheses, by the way. Yeah, I don't know. I know it's denoted by cosecant. I'm not sure. I think you could write like this, actually, the more I think about it. You could do an arc cosecant. You could do that also. That's a possibility. So, okay, so let's now do these examples. Here's how you want to think of it. Set this equal to theta. So then, cosecant theta equals -2, or sine theta. So theta okay, let's back up a little bit here. Let's think about what I just did. It's inverse. The output has to be an angle. Has to, right? We're doing inverse. So how do I write back to the original function? I write it like that, right? Because wouldn't how do you undo an inverse? You just simply switch into the outputs, right? Now -2 is my output, theta is my input. So cosecant theta equals -2, but if that's true, wouldn't sine theta equal -half? So I use this as a bridge so that I can actually do it in a graphic calculator or just think about it more easily on the unit circle. And if that's true, wouldn't theta be the inverse sine of -half? Yeah. And what's that going to be on the unit circle? What was it? Say what? Good, thank you. -6. Okay. That's a more drawn out way of doing it. However, here's a quick and easy way. The quick and easy way is you simply just do inverse sine of its reciprocal, as you should, because isn't cosecant the reciprocal sine? But you don't flip. You don't flip the whole thing. Whatever you do not do this though. This is not true, and of course I know that's that right there. But I'll put this in green. This you do not do. It's not that. And the reason why it's not that, because of order of operations. Order of operations. That's not true, because you have to first respect the fact that this is an inverse sine. You can't just flip it. It doesn't work that way. You'd have to kind of, it's kind of like parentheses, right? You got to take care of that. You got to take care of that parentheses first. And respect inverse cosecant, which is actually the inside is h over o, hypotenuse over opposite. Now on opposite over hypotenuse. So it doesn't work that way, unfortunately. You can't do that. So you have to be somewhat intentional, like, oh, okay, well, cosecant theta is -2. Oh, sine theta is -1/2. Oh, theta is inverse sine -1/2. Let's use unit circle. Or the quick and easy way, just flip the input. So now you know that, we can do the other two more quickly, right? That's gonna be the inverse sine of 1/√2. Where's that gonna happen, guys? That's easy now. Done. Easy peasy, right? Or 45 degrees. Yeah. That's what I was saying in School G. In School G, I was saying the exact same thing, right? I said for inverse cosecant, blah, 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 go with the reciprocal trig function. For example, if you have inverse secant of 2, think of it as the inverse cosine of 1/2. Then you should be good, right? Which, by the way, that would have been pi over 6. Sorry, pi over 3. All right, let's keep moving. C. For C, secant 2 pi over 3. That's what's cosine 2 pi over 3? That's -half. I'm sorry, go say, Kieran. -2. -2, right. Okay, so that's -2. I know that. Because remember, that's 1 over cosine 2 pi over 3, which is 1 over -half, which is -2. Okay, I know that. Now, here, how do I think of it? How do I think of this? Inverse sine of what, guys? Which is going to be at -pi over 6. Or -30 degrees. That's how you want to think of it. Yeah, go, Kyle. Yeah, go. Okay. Let's keep on moving. And just so I pace things, yeah, I'm not gonna get to part 7 today. That's crazy. We'll save that for Monday, but we'll still do a review on Monday because part 7 is pretty short. Okay, inverse secant. Let's do that really quickly. We know everything's gonna switch now. So if I do y equals inverse secant of x, because again, if you were to extend those graphs, that would totally fail the horizontal line test. So you want to force the issue that it will be a function for the inverse. And so I'm going to have a domain and range switch from the original, as I always do for inverses.
Is that? Is the domain, the second parenthesis, for the domain of the first one, is that inclusive or exclusive?
The pi over 2's
Yeah,
exclusive.
for both exclusive.
Yeah, because you have the asymptote. So I'm going to have an asymptote here, guys. And everything switches. So I'm just trying to, my eyes are not the best sometimes. So I'll do a little table. Negative root 2, 3 pi over 4. And negative 1 pi. And then 1 and 0. Wait. I think 5 over 2. Okay. And then 1, 2. Okay, and just that's pi. That's y equals pi over 2. And you guys see that this is pi over 4, right? And 3 pi over 4, you guys see that? All right. 1 comma 0. And root 2 comma pi over 4. So there's that. And then here, negative 1 comma pi. And negative root 2, 3 pi over 4. So you see how pi over 2 is left out of the range, as it should. It goes from 0 to pi, but pi over 2 is left out. The domain, 1 to infinity, for the right branch, left branch, negative infinity, negative 1. We're good. Okay, that's how that graph looks. That's inverse secant. So for down here, the unique angle y in the interval from obviously 0 power of 2 comma pi. The domain we already know again. I know we're just repeating ourselves. The range. And it's denoted by this, or arc secant x. Okay, we're cool. It's good. Okay, so now let's try some problems here. And let's look at example 3. And then we're going to kind of jump to some other ones down below. Okay. Example 2 and example 3. Let's talk about it. Okay, inverse secant of -1. So if you think about it, that would be the same thing as saying inverse cosine of -1 is still. Because what happens if you flip -1? It's still -1, right? Where does that happen? Where's cosine -1 in the inner circle? Pi, there we go. Or 180 degrees. All right, here. See what I just did? The inverse secant of inverse cosine by flip facts. Right now I kind of know what's happening. I mean, I said secant with theta and say secant theta equals -√2, and then cosine theta, -1/√2, and then do the inverse cosine of that. But we just need to flip the input. Where does that happen? Well, what quadrant am I in when I'm inverse cosine -2? And what's that value going to be? Good. Excellent. So that's 1 over sine of 3 pi over 4. What's sine of 3 pi over 4? So it comes 2/√2. And what's final answer, Kieran? √2. Once you rationalize the denominator, right? Okay. Okay. Let's look at example 3. Questions? Nope. Let's look at example 3. Oh, that's a fun one. I like that one a lot. I'm not going to do inverse cotangent. I think just in interest of time. The graph, I think, we did in Desmos, but yeah, I'll also have to wrap this up another time. But let's look at example 3, and then I'll give you guys a homework quiz. Okay, example 3. That's an angle, right? That's an angle. And come to think of it, was there a homework question like that? Hope not. Okay, good. Because there's no way you could have done that. Because, all right, that's good. Because that'll be in the next homework. That's good. All right, I like that. All right, so that's an angle. So it's the same thing as saying inverse cosine of t over 1. That's the same exact thing. T is greater than 0. What quadrant am I in? Q1. Just foundationally, that makes sense the word, fundamentally. What is cosine? Ka. Adjacent or hypotenuse, right? So we know that cosine theta equals t over 1. That's adjacent. That's hypotenuse. Therefore, that's t. Does that make sense? And then let's call this y. And it's positive because it's opening up. So y becomes √1 minus t squared. Yeah, this is lovely. This is now we're getting some really fun stuff. I was really bored with the other stuff. This is fun. Okay. And what do they want? They want the sine of that angle, right? So now I know what theta is, or I have a vague idea what to do. I have the triangle all figured out. What's my sine going to be? That's final answer. Yeah. You could kind of verify the work if you made up a value for t and actually use a calculator and got like a weird answer and then did a sine of it and then checked it to see if it's consistent with root 1 minus t squared. You could do that as a strategy, I suppose, but that's what happens. So, okay. The more I think about it now, I think I might make a short video on the rest of these notes and have that as a homework, just so you guys can have that done, and I'll give you guys a homework on it. And the homework will be number 10, which definitely I think we can handle. There's some other stuff that's going on there too. I'm gonna have to let go 78 through 86. I don't think you guys can do that. So, all right, let's do the homework quiz. Let's stop the video. Math.